Hello, good evening to all of you. Now, today we will discuss the project preparation aspect. We will discuss pre-feasibility and the feasibility study of a project. First of all, we should discuss the feasibility study. The next stage is project preparation. It involves a feasibility study for all, but the simplest and most routine projects. As the term implies, its purpose is to establish the feasibility or justification of the project, both as a whole and in its principal dimensions, technically, economically, financially, socially, and so on. Each dimension must be analyzed both separately and in relation to all the others. This is done in a series of approximations that test different technical approaches for their economic benefits and financial viability. The purpose of the analysis is not to determine whether a particular idea is good enough to proceed with, but to arrive at the best one possible under the circumstances. Although the feasibility study should be designed with due regards for cost, that this is not the place to skimp. If done well, the study is bound to pay for itself many times over through cost savings or increased benefits. Now, we should think how we prepare the pre-feasibility study. The formulation of techno-economic feasibility is certainly very costly and time-consuming task. Although such a study enables a definite decision to be made on the project. So before assigning funds for detailed feasibility study, a preliminary assessment of the project idea must be made in a pre-feasibility study. The main or principal objective of preliminary study are to determine whether the investment opportunity is so promising that an investment decision can be taken on the basis of the information elaborated at the pre-feasibility stage. Next, the project concept justifies a detailed analysis by feasibility study. Any aspect of the project are critical or its feasibility and requires in-depth investigation through functional or support studies. Support studies such as market surveys, laboratory tests, pilot plant tests, etc. The information is decided that the project idea is not either a viable proposition or attractive enough for a particular investor or investor group. A pre-feasibility study should be viewed as an intermediate stage between a project opportunity study and a detailed project analysis or feasibility study. The difference being primarily the detail of the information obtained. Accordingly, it is necessary, even at the pre-feasibility stage, to examine broadly the economic alternatives of market and plant capacity, means demand and market study, sales and marketing, production program, and plant capacity, material inputs, location and sites, project engineering, technologies and equipment and civil engineering works, factory overhead, administrative overhead, sales overhead, manpower in the terms of labor and staff, and implementations. Thereafter, financial analysis. Financial analysis, that is, we have to analyze the investment cost, project financing, production cost, and commercial profitability also. When a project opportunity study is conducted in respect of an investment possibility, the pre-feasibility stage can be dispensed. It can also be bypassed when a sector or resource opportunity study contains sufficient project data to either proceed to the feasibility study or determining its discontinuance. A pre-feasibility study is, however, conducted if the economics of the project are doubtful, unless a certain aspect of the study has been investigated in depth by a detailed market survey or some other functional study to determine the viability. Shortcuts may be used to determine minor components of investment outlay and production costs, but not to determine major cost components. The latter must be estimated for the project as part of the pre-feasibility study, but it is not necessary to depend solely on firms' quotations. Now, we have to study some of support functional studies also. Support or functional studies in industrial programming covers one or more but not all aspects of an investment projects and are required as prerequisites for or in support of pre-feasibility and feasibility study, particularly large-scale investment proposals. Support studies we can classify as market studies of the product to be manufactured, including demand projections in the markets to be served, together with anticipated market penetration. Raw materials and input studies covering present and projected availability of raw materials and basic inputs to the project and the present and projected price trend of such materials and inputs. Laboratory and pilot plant tests, which are carried out to the extent necessary to determine the suitability of particular raw materials. Location studies, particularly for potential projects, where transportation costs are significant and a major determinant. Economies of scale studies, which are generally conducted as part of the technology selection studies. These studies are commissioned when several technologies and market sizes are involved, but the problems are confined to the economies of scale and do not extend to the intricacies of technologies. The principal task of these studies is to evaluate the size of the plant that would be most economic after considering alternative technologies, investment costs, production costs, and prices. The studies normally take several plant capacities for analysis and development, the broad characteristics of the project, computing results for each capacity size. Equipment selection studies, which are required when large plants with numerous divisions are involved and the sources of supplies and the costs are widely divergent. When very large investments are involved, the structures and economics of the projects depend heavily on the types of the equipment and its capital and operational costs. Even the operational efficiency of the project is a direct function of the selected equipment, where standardized costs cannot be obtained. Equipment selection studies become imperative as a support to techno-economic feasibility study. The content of the support study vary depending on the nature of the study and the projects under consideration. Since it relates to a vital aspect of the project, the conclusion should clearly provide direction to the subsequent stage of the project preparation. Support studies are undertaken before commissioning a pre-feasibility or feasibility studies. When for instance the basic inputs may be decisive factor in determining the viability of the project and the support study may show negative results. Support studies are commissioned separately but simultaneously with a pre-feasibility or feasibility study when detailed work required for a specific function is too involved to be undertaken as part of the feasibility study. A support study is undertaken after completion of a feasibility study when it is discovered in the course of the study that it would be safer to identify a particular aspect of the project in much greater detail, although the preliminary evaluation may begin later. The cost of support studies must relate to that of the feasibility study, as one purpose of such studies is to economize during the feasibility study. Now come to feasibility study. Feasibility study must provide a base, technical base, economical base, financial base, and social base for an investment decision on an industrial project. It should be defined and analyze the critical element that relates to the production of a given project together with alternative approaches to such production. Such a study should provide a project of a defined production capacity at a selected locations using a particular technology or technologies in relation to defined materials and inputs at a given investment and production costs and scale and sales revenues yielding a defined return on investment. To achieve this objective, an iterative process is initiated with a cycle of feedbacks and interlinkage covering possible alternative solutions for production programs, locations, sites, technologies, plant, machineries, electrical and civil engineering and organization setup that have to be harmonized with a view to minimize investment and production and costs. If the resulting data shows non-viable projects, several parameters and the production programs, material inputs or technology should be adjusted in an attempt to present a well-defined viable project. If feasibility studies should describe this optimization process, justify the assumptions made and the solution selected, and define the scope of the project as the integration of the selected partial alternatives. If the project is not viable, despite all alternative reviewed, this should be stated and justified in the study. Final estimates on investment and production cost and the subsequent calculations of financial and economic profitabilities are only meaningful if the scope of the project is defined unequivocally in order not to omit any essential part and the cost pertaining to it. The scope should be defined in drawing and schedules which should then serve as the supporting structures during further project work. The contents of most feasible study is more or less the same or similar, though there may be considerable differences in orientation and emphasis depending upon such factors as the nature of the industry, the magnitude and complexity of the production unit contemplated, and the investment and other costs involved. A satisfactory feasibility study must analyze all the basic components and implications of an industrial project, and any shortfall in this regard will make the usefulness of the study limited. The feasibility study is often misunderstood and often deliberately misused by suppliers of equipment or technology. Frequently, an outline of a project primarily oriented to the supply of equipment or the choice of particular techniques is considered as feasibility study. Sometimes, production or sales estimates are based on the experience gained in an industrialized environment and bear little relation to the conditions within which a project has to operate. All these studies are unrelated or unadapted to local production factors. They can be misleading and result in misapplication of resources, as has often occurred in many cases. A feasibility study must be related to available production factors, local markets, and production conditions, and this involves an analysis which has to be translated into costs and income. The feasibility study may be either market-oriented or based on material inputs. That is, it derives its initiative from an assumed or existing demand or from available material inputs such as raw materials or energy. In view of the determinants, position of the demand and market analysis within the feasibility study, it is ranked before material inputs. It should be kept in mind that all feasibility study are interrelated and their ranking within the study is not indicative of the actual sequence of the preparation. The feasibility study is not an end in itself, but only a means to arrive at an investment decision that needs not agree with the conclusions of the study. In fact, it would be rare to find investors' response so flexible as to fully conform to the results of such a study. Investment decisions has to be taken during pre-investment stage, and the implications of a particular investment must be analyzed with great care prior to such decision being taken. In view of the enormous range of industrial activities, no uniform approach or pattern can be adopted for all types of industrial projects, which can be of various categories and magnitudes, and the emphasis on and consideration of different components vary from project to project. However, the most industrial projects, a broad format can be prescribed, bearing in mind that the larger the project, the more complex will be the information required within which a feasibility study should be prepared. A thorough study of the feasibility stage reduces the likelihood of difficulties during implementation by accepting the problems that may arise and devising measures to deal with them. For most types of projects, detailed engineering should be completed, relatively reliable cost estimates made, institutional arrangements specified, and financial plans worked out for before fund, whether from an external lender or from domestic budget, are committed. One of the most common cause of delayed or poor implementation has been inadequate or incomplete project preparation. The pervasive shortcomings of the project preparation work has been to underestimate the cost of implementing projects as well as the time period. This optimism on the part of project planner is found in all projects, large or small, simple and complex. The cost overrun can have adverse effects on both the financial and economic viability of the projects. Providing for contingencies in the cost estimates help to improve their accuracy. One of the thorny issues of project design is how to achieve the right balance between simplicity and complexity. Projects that have a few well-defined objectives and are based on proven technologies or approaches stand a better chance of being implemented successfully than the projects that embody many objectives or unproven methods. Given the scarcity of trained staff, managerial skills and administrative capacity, special efforts to simplify objectives and to select technologies and approaches that have a high probability of working in a particular environment have paid off very well. At times, project suffers from being too restricted in scope. There are several examples of projects that did not yield their full benefits or even failed because the need for complementary investments and activities have not been recognized and met. This is true of many kinds of agricultural projects in which research, extension, credit, inputs, marketing, processing and storage are all necessary elements. The same is the case with urban development and highway maintenance projects. Projects can be too simple as well as too complex. Indeed, the swing of the pendulum in recent years towards greater complexity reflects the unimpressive result of the project that were too simple. There is a middle course, that is, even when a multi-component project approach with its inherent complexity is necessary, it is possible to concentrate efforts and resources on those elements that are essential to achieving the primary objectives and to leave desirables but secondary objectives to subsequent projects or to parallel operations outside the project. Although the scale of project or the timing of its component can be another way of matching complex projects designed with limited implementation capacity. Furthermore, the administrative project capacity of an agency can be expanded under a project through well-designed technical assistance. So this is all about your project preparation, pre-feasibility and feasibility study. Now we will discuss project formulation and analysis in the next class. Thank you very much. Take care of yourself. Don't go outside from home and keep yourself safe. Thank you very much. Good night.